right, I'm going to go ahead and start examples for step 6. We'll do an ANOVA and we'll do correlations. So first I'll go ahead and just start writing an analysis of variance was performed to determine if. Now let's check out all the possible independent variables. So possible independent variables are, the first one is the hours worked. So we're looking at how to split up these people into more than 2 groups. So hours worked could be less than 5, 6 to 10, 11 through 15, etc. All right, another one, if I keep going through this, well, eye color is another way to split up these people into more than 2 groups. And we've got, you know, whatever it is, hazel, brown, green, black, etc. Let's see, and if I keep going, there's cell phone, Android, iPhone, I don't own a phone, and I believe maybe even other. Let's see, what else is there? There's GPA, that's not, we don't want to split that people up that way. There's morning, if you're a morning person, I believe it's on a scale of 1 to 4, 1, 2, 3, 4. There's also math grades, A, B, C, D, and actually I think F is also one of them. So those are all of the possible independent variables. Dependent variables, we're looking at variables that can be summarized by a mean. So we're looking at, is the mean different between the different levels? We can, for the mean, we basically have age, units, drink, chocolate, what else? GPA, math talent. Those are all things we could find the mean of. We will work with hours worked and GPA. So I am going to separate everybody into groups by hours worked, right? So I'm going to sort by hours worked. So I'm just going to go Control A, data sort, and I'm going to sort by, and I know it's a little hard to see, but I'm looking for hours worked. Okay, the only problem with the hours worked is the way that I wrote it. I wrote, oh, it's 5 to 10, and then in words it says less than 10, etc. So that's okay, it's still sorted. I just wanted to actually put it in the order that I want it to. And like I said, I have, well, let me do less than 5, 5 to 10, 11 to 16. Oh, great. Let's try that. 5 to 10. It was just turning it into dates. 11 to 16, and then no, it's 11 to 15, 16 through 20, etc. Okay, so at this point, I've got my column heads, and I'm going to go through. Right here, this is 5 to 10, so I'm going to look for less than 5. And in fact, I'm just going to go ahead. I want to hide everything that I don't need, just so I don't get confused by it. So I don't need all these weekday drinks. All I need is GPA. Okay, so here I go. I'm going to go look for the less than 5. There it is. These are all of my students who work less than 5 hours, and their self-reported GPAs. Just cut that and paste it into the less than 5 column. And then let's see, I'm looking for 5 to 10, that's these guys. Oops. Any questions? I know it's a little hard to see what I'm doing here, so are there any questions in what I'm doing?
I was just wondering if you can go back to the Control A, sort data, and do it one more time.
Yeah. 5 different, I had 5 levels, so I had to do that 5 times. You have 3 levels, you have 3 different columns to do. But that's not really, that will of course change your null as mu1 equals mu2 equals mu3. Now, if you haven't already, I'm going to go to options and then add-ins and then analysis tool pack. Okay, mine already has it. You should have some sort of data analysis, and it's different for Mac, but you can look it up. How do you do a analysis tool pack? Okay, so I'm going to do data analysis and then okay. It says input range. I'm just going to highlight the columns. It's grouped by columns, and I do have labels in the first row. So that's pretty much all. I'm just select the columns, and then I'm going to click, yeah, I do have labels. I would suggest the columns that you're testing, less than 5, 5 to 10, 6 to whatever it is. All right. Well, you get the idea, right? You got all the different columns of level of the hours of work. You select all of those, and then I click OK. All right, let's zoom in so we can actually read what this says. So first of all, it's giving me my summary statistics. It looks like a lot of you either don't work or work just a couple hours, right? Less than 5 hours, or you work more than 20. And then there's obviously a good number that are in between, but majority looks like, this would sort of be an inverse or like that if we graphed it. Okay, here's our average GPA. By the way, just curious, does it look like there's a difference between these GPAs, these groups? How many people think that there is a difference just by looking at the GPAs?
Yes.
Few of you. How many people think there's not a difference? Some of you may be just looking at the p-value. And if we look at the p-value, what does it tell us? Is there a statistically significant, because by the way, there is a difference, right? They're not all the same. But is there a statistically significant difference?
Yes.
What's our p-value? Somebody tell me, what do we compare our p-value to? Alpha. Okay, we're looking at p-value and alpha. Remember, this basically is saying, this is sort of the cutoff probability to say, is this unusual? This was the first, I don't know how many weeks of our class, and you're like, oh, is this unusual? Oh, okay, well, if the probability is less than 5% or it lies in the tails, then we say, yeah, that's unusual. Okay, so this is a step 6. We're not actually, we don't have, it doesn't say, take your significance level to be blah, blah, blah. So what do you tell me, what's our significance level? 5%. Otherwise known as 0.05. All right, what is our p-value? 0.47. Thanks. It's definitely greater, right? Okay, so what does that mean? Fail to reject. Okay, so let me start.
So there's not a significant difference.
There's not a significant difference between, and that is not what the other research has shown us, by the way. They've shown us that if you work more than 20 hours a week, that generally that people will get a lower GPA. Okay, so let's see. I'm going to say fail to reject the null hypothesis. There was not sufficient evidence unless you reject the null. If you reject the null, then you'll say, there's at least one difference. There's at least one mean that is different. How do we say it? Technically, we would then go on and do a post hoc Tukey test and say which one was different, but we're not going to do that in this class because that's obviously, you would really want to know that. Like, oh, okay, it's different. Well, which one's different? Is it for people who don't work or people who work a lot or, So, okay, but we're not going to do that part. Let's see. And then I want the F value, the degrees of freedom. Okay, so now I have the numbers. Let's see. I am going to hide this one. I'm going to call this one mean, this one standard deviation, group I'm going to hide these and do the same format for standard deviation. The only other thing here is it's not in Times New Roman. All right, so here I go. Here's my table. I've done it in Excel. It was actually already done for me in Excel, but I'm just going to copy and paste it. Right there. And then, one more thing, which is you're supposed to do a box plot for these. All right, and unfortunately, it would be really if you, because you should just be able to in Excel, in my opinion, just to say, all right, do a box plot for these. But instead, it makes it difficult. So it's not actually that hard. I'm going to show you. So we're going to use an online program to do the box plots, and I'll just copy and paste it from Excel, put it in there, and it'll do box plots for me, and I can download it as a picture. By the way, this program also does ANOVA and also does linear correlation. But you just have to do, well, I'll show you how to do it. So let's see. I don't have it open. Let's go ahead. I'm just going to search for create box plot. And if you scroll down, I think I told you guys on Tuesday, if you scroll down, you're going to look for Plotly, plot.ly. I don't know the entire website name. Come on. Oh my gosh. There we go. Here it is, box plot generator. Plotly, or you could actually probably just type in Plotly if you wanted to search that. All right, box plot generator, I click on that. It says create a box plot online. Okay, cool. The trace is like each box plot that you want. So depending on how many levels you have, that's how many traces you want. Let's see, I have, what was it? Was it 5? All right, because I had the less than 5, 6 to, 5 to 10, et cetera, et cetera. So I need 5 box plots. In fact, why don't I just go to Excel, and I'm going to go to my other sheet. Where was it?
You deleted it.
No, it's right here. It goes. By the way, when you do any kind of test on Excel, it opens the results in a different tab. It didn't like delete anything. It just opens it in a different. It opens the results in a different tab. Okay, so this one, I'm just gonna copy and paste into all right, so that's all right? Control-C, Control-V into Plotly. I'm a little nervous about having titles in there because it doesn't say it has labels. And so I'm just going to know which one's which, less than 5, 5 to 10, et cetera. I'm going to delete the labels. All right, now I'm going to do, let's see, 1, 2, I'm going to have 5 traces. First one, I'm going to click box plot, values in A. Then next one, I'm going to click box plot and values in B, etc. Box plot. Where'd it go? Box plot, values in, no wait, I already did that one. That was supposed to be B. Wait, I'm confused. That's supposed to be C? Sorry. All right. And then here, keep me honest, we're doing D, and then here, box plot, and we're doing values in E. Okay, you can edit these. Let's see, what was this? Was GPA, right? And then, oh gosh, so hard to do these. I think you edit them here.
No, you have to click the A on the Excel.
Oh, you click A up here?
No, yeah.
Rename header. Thank you. So this would be less than 5. Confirm. Okay. And then same thing. Do you guys mind? Well, whatever. We'll just do it. 5 to 10. Rename. What was it? 11 to 15. And then 16 to 20. And then, come on, rename header. 16 to 20, and then more than 20. Okay. Come on. Thanks, Jamin. All right, down here, I'll put hours worked. Okay, and over on the left here, I have save. If you don't have, if you want to save, like I've created an account, I've just put in my email address. I'm not worried about Plotly, but you don't have to create an account for it. You could just like sort of, you know, do a screenshot and then take a picture, you know, take a picture of that. I think if you want to save something that they make you put in your email address. That's completely up to you. If you don't want to do that, then maybe get somebody else in your group to do it, or again, you could take a screenshot and then just like cut it out. But I'll go ahead and save it. Let's see. What am I going to save? This is GPAs. This is GPA and working hours. Save. Now, if I go up here and go to my files, I clicked on view, and then I'm going to click export as JPEG. And it downloaded right here. Open that up. And I'm just going to write what this is. Figure 1, box plots. It's a little big. Okay. So that took a little while. But that's how you would do a test on ANOVA. And again, probably one of the hardest parts is because you have to separate 5 things, like copy and paste the 5 things, and because you have to go into a different program to do your box plots rather than Excel. So I encourage you to mess around with Plotly. It's actually really cool. I mean, you can get a professional subscription, but for free you can do a lot of stuff, and you can also get a student subscription, whatever it is, prescription to Plotly. All right, so let's do one more here, and then we'll go on break, which is linear regression. I promise that won't take as long. Linear regression. So let me back up for a moment, and let's talk about what the null and alternative hypothesis is for linear regression.
Row equals 0.
Shoot, man, what is row?
I'm sorry,
What is row?
Oh, that's the R in
Population.
Oh, that's like the population R. What is R?
I don't know.
It's the Pearson correlation coefficient, which is the Pearson correlation coefficient. What does the Pearson correlation coefficient tell us?
How much it's either positively or negatively correlated.
If it's moderately, strongly positive correlated, not correlated, or moderately, strongly negatively correlated. Remember, if R is equal to 1, perfect positive correlation. If R is equal to -1, perfect negative correlation. And if R equals 0, no correlation. Okay, so basically this is saying do we have no correlation? No, and I should say linear correlation, or do we have linear correlation? This is what this one says. Of course, I could do positive correlation, negative correlation, or just, I don't know, but tell me if there's a correlation. Okay? So, I need, does anybody remember the examples that we did? We did the examples for linear correlation. What's one of them?
Is it just sleep and?
Yeah, I was going to say, it's just 2 days ago. Sleep and happiness, right? So I asked, and I don't remember who told me, well, I don't know, is Ken here keeping you up?
Yep.
Yeah. So I should have asked David last time, or Mr. Yang, how many hours he slept with the newborn, but how many hours did you sleep?
5.
5? Okay, well, you got a little sleep anyway. So, 5 hours of sleep, how happy are you?
It's, I think it was 6.
6, all right, 5 and 6. Okay, so, but remember here, those were both basically ratio variables, right? How many hours did you sleep? And then you have we'll use the happiness as a ratio variable. And there were points, right? It was point XY, which was sleep, happiness for one person, sleep, happiness for another person, etc. So you have, let me just do it like this, right? You have 2 ratio variables. Oh shoot, I erased it. But it seemed like Sarah was telling me all the ratio variables as we went through it, which was like GPA, whether you, height, drinks, chocolate, whether you think people are born with math talent, income, there we go. Okay, and age. So, let's try and create a question here. Are these 2, out of all the variables we just said, or maybe I need to bring them up again, but out of all these variables, where'd they go? Oh.
Well, now we're doing linear regression, right?
Now we're doing linear regression.
So that would kind of be like people between the age of such and such have a higher affliction for chocolate.
Oh, yes, we could definitely do that.
Okay.
We could do student survey. Sorry, I'm just trying to open it up again because it was all messed up. Okay, so we could do, is people's taste for chocolate correlated to their age, right? So depending on, if given somebody's age, okay, so let me say this. Should we do that one?
Yes.
Why not, right? So then we say, like, should this be age or chocolate? You know, wherever it is, but like, which one should be which? So let's see. X is the independent variable. Let me just write it this way. Y depends on X, right? Is the dependent variable. So, does age depend on chocolate score? Or would it? Right? We don't know if it does, but would age depend on chocolate score, or would chocolate score depend on age? It would be really weird if age depended on chocolate score. Like, I'm forever young because I love chocolate. No? All right, age does not depend on chocolate score. We have, so this is chocolate score, and this is age. X age, Y chocolate. Again, this is really obvious because age does not depend on something like that. It's really obvious that age will be independent. However, like I said, and sometimes it's not clear. So if somebody in your group says IQ depends on ADD score, and if another person in your group says no, ADD score depends on IQ, I don't know if either of you are right or wrong, right? You could do either one, right? And you could argue for either one or do some research or whatever, but sometimes it's not clear. Okay, so let's go ahead and start writing this. I have a simple linear regression analysis was performed or was conducted at the 5%,